Good evening, class. Me and the Squishmallows here, ready to start section 1.6. All right, let me bring up 1.6 handout. Oh, I keep forgetting. I gotta hit screen share first so you can see what I see. There we go. It's all right. Let's talk 1.6. 1.6, we're going to start delving into design experiments. But a quick refresher is that we talked previously that what? Observational study, we can state that there's an association between the explanatory variable and the response variable. Explanatory variable is what we are observing to see what happens with the response. We cannot claim causation. Instead, we can claim correlation or association. All right. To determine how changes in an explanatory variable can cause causation, changes in response variable, we need to conduct an experiment. So if we want causation, that is an experiment. Right? All right. In an experiment or designed experiment, whichever, it is a controlled study conducted to determine the effects varying one or more explanatory variables or factors have on an response variable. I'm still just going through some basic terminology. And when we have factors that we tweak, these are called treatments. So it's any combination of them. We can have one that we tweaked, or maybe we had two. We don't tend to do a lot because we want to keep it controlled. But these are called treatments. Okay. Now, what we study to keep it more scientific and, I hate to say this, dehumanized, because we want to focus on what's going on. And it's not just always humans that we are studying, but the experimental unit. What are we studying? We also call these subjects. Well, an experimental unit or subject is a person, object, that is some well-defined upon which item. It's in other words, I say person, places, or things. But it's a person, it's an object, it's an animal, where we can have a treatment applied. That's the reason why I say person, places, or things. Can we not apply a treatment to an object like grass, plants, farmers? We do treatments to the crops. Did that caused our crop to do better? Did it not? So people, places, or things. Those are our subjects. What are we studying? Now, in an experiment or a designed experiment, we always have to have a control group. This is the group that we are holding steady. That's our baseline, just like it says. This is what we're going to compare the experimental group to see. Sometimes the control group is like if we were studying a new cold med. Well, we're not going to not give the control group something. We may not, that's just cold, but typically we give them the old standby. Let's say Tylenol cold comes out with a new formula. Well, the control group would get the old formula. The experimental group will get the new formula. And we're going to see which one worked better. So control group is our baseline. 4. Now, sometimes we have something called placebo. Now, placebo is, like it states, it's the sugar pill. It's not harmful medication. And we use this because we don't want people to know whether or not they're getting the meds. Now, there was actually a time that a placebo can have such a, if depending on the cell of the placebo, the brain is a wonderful thing, because some people think with the placebo that they're getting the real drug. That the next thing you know, even though they may have gotten the true sugar pill, they experience something called the placebo effect. Meaning that sugar pill all of a sudden gives them the same effect as the drug. They didn't get any drug, got nothing. They can have the same side effects, the same pluses. So it's kind of strange. Now, I hate to admit this, but I mean, our poor soldiers, if you've served, thank you. But there's been times that they've used that placebo effect in a kind of a beneficial way, because back in like World War II and more like into the Korean War, they didn't always have pain meds where they needed it. And they would give soldiers placebo effects, selling it to the soldiers that they were getting pain meds. And all of a sudden they were out of pain, even though they had no pain meds. So, as I said, a lot of times it's the cell factor. If you think you're getting something that's really potent, next thing you know, great. And it actually worked. You don't always want to do it because, I mean, if you got the pain, you know, in this case, you want the pain, you really do want the people, because it doesn't work 100% of the time. But if you got nothing, you can sell a sugar pill real quick. And if 75% of the people are no longer in pain, why not do it? And that's something that seriously happened back in a couple of the major wars. Supply lines weren't always the best. And people didn't know about the placebo effect as broad as they do now. A lot of people do know about the placebo effect now. It's not as easy to sell, but we still get the placebo effect in like our drug stuff, because people get themselves internally worked up thinking, yeah, I have to be getting the new drug. I have to be. I feel so much better. And they're not. It's the brain. The brain is a wonderful thing. It can do more than people give it credit. All right. Now with that, I hate it when that thing jumps up. There's times with the medical research and such that we don't want to disclose who's getting what. And I'll be honest, blinding's more than that. When I do research, I don't want to see names. That's a form of blinding. I don't want to know. So blinding is when we don't tell the treatment if it's which one you're receiving. Now, there's two forms of blinding. We have the single blind. Not blind. Blinding happens when we don't want, definitely the patient never knows. The person who's the subject, whether or not they're the experiment or the control, we don't tell them. In a single blind, only the subject does not know, where the person running the research and the medical people, they know whether or not they're getting the treatment. They know which one. They know whether they're getting the drug or they're not getting the drug. Now, the problem with that is some people start getting excited and it can tip their hand. Oh, we're getting a response out of this person. Oh, so they must be getting the real thing. In a double-blind experiment, neither the researcher or the subject knows who's getting what. That way, even the researcher is blinded. Now, there is a master list. And there's a reason for that. It's for ethical reasons. What if you're having an adverse reaction? They need to know what they just gave you. And there's times that they will break a double blind because of adverse health reasons. All right. So there is still a master list and it's encoded. So, I mean, they break it and they look at the coding and they can take it backwards. But that takes a little effort to break. So in drug tests, they don't typically give placebos unless it's something like cold meds. If you're talking like cancer research and all that, they're still going to give you the old tried and true versus the experimental. That's the reason I said like old Tylenol versus new Tylenol cold. There is no such, but I just given examples. They typically do give you something. It's not just a flat sugar pill. All right. So let's talk about the steps. Because before we run an experiment, the first step is to design it. And there's a lot of planning to it. Because we don't, hey, okay, we're going to run out and do this experiment and I'm going to give this person this and that person that. Well, no. We just don't run willy-nilly. There's a lot of planning that goes into the experiment, and we call that the design. And we start with identifying what it is we're going to be doing. It's that statement of the question. What is it that we want to find? Well, in a design experiment, we want to know what we're going to be researching. And it needs to be as well defined as possible or explicit. And we have to even nail down all the response variable that we're looking for. What is it that we want to happen when we apply this treatment? So that's the first thing. What are we looking for? So what is it that we are going to tweak? What is it that we need to hold steady? Remember, in a design experiment, we control as many of the variables as possible. All this starts in the beginning. So this is the next step. Determine the factors that affect the response. So that's the other variables. Do we manipulate those two, or do we hold it steady? Step 3, how big of a sample size do we want? Is 20 good enough? Or do we need 200? I'll tell you right now, 20 is not enough. But we need to compare that number of subjects or experimental. I hate calling them experimental subunits. I do. It's subjects. We'd all love to be able to go out and play. I'm going to do 5,000 people. That's a big number. That's a good number. Yeah, but sometimes we also got to keep in mind our money. How much money are they willing to spend? The more the subjects, the more it costs. So you have to find that happy median. And we have to, there's more things, as said, section 9 to 2, where there's more to it than just the bigger the better. There's sometimes we consider it the sample to be now too big. We'll talk about towards the end of the semester, when is it too big, right? Once we've got this all started, we need to decide who's the control and who's not. And if the control, we need to set what's the level of the control. So once we set that level and everything else of our control group, well, how do we know who goes to who? Who goes to control, who goes to the experimental unit? That's when we start randomly selecting who goes where. Do you go to 1 or do you go to 2? Finally, after all this planning, assigning people, we finally get to start the experiment. Now, when we conduct experiment, we need to be able to have replication. So in other words, if I'm going to do this, I need to be able to replicate it for another round. I just can't do a one and done. Now, as I'm doing the experiment and being able to replicate it, I need to collect, and the process, collect the data and process it as I go. I just can't let it go, then try to back up. Nope. Once I've got everything done, the experiment is done, I finally get to do the math. A lot of work goes in long before the math hits, and that's testing the claim. Once I have tested it on my sample group, I make an inference to the population. This is the inferential statistics I talked about and why it's important to understand when does it come into play. I may have studied 200 people, but I'm now, after I've done the 200 people, I'm going to make an inference that what happened with the 200 people should happen with the population. I make the leap, right? The best designed experiments will account, we've plotted it out so well that We've even figured out a potential of confounding variables. Talked about that previously. We should also be looking for lurking variables. Could there be a lurking variable that, all right? We try to control for all that. If we have confounding variables, can we separate it from the explanatory variable? If not, we may have a problem. All right, next definition. A randomized design is when each experiment unit or each subject is randomly assigned to a treatment. That's the official term. But remember what I say up here? Randomize. We do randomized design all the time because we want everything to be above board as possible. We don't try to, in honest statistics, let me phrase that correctly. We don't try to tilt the scales purposely. What in the world? All right, so let's talk about example 2. And I don't know why it starts with example 2. It really should start example 1. We have a pharmaceutical company has developed an experimental drug meant to relieve symptoms associated with the common cold. I think this is maybe the reason I had to think in the cold. The company identifies 300 adult males ages 25 to 29 who have the common cold and randomly divide them into 2 groups. Group 1 is given the experimental, I'll get it out, sorry, drug, while the group 2 receives a placebo. It's just a cold. After 1 week of treatment, the subjects report whether they still have cold symptoms or not. In other words, whether or not did they get better. Now, you see this 1.610. If you go into if you go into the data sets the book has, that's what it's telling you. You can actually see the data and the research behind this. All right. So reading through this, the first thing, stop and think, what is the response variable? In other words, what are we checking? What are we testing? It's whether or not they still have a cold. All right. So thinking of that, think of some factors. That could potentially weigh into this. First of all, let's think of the controlled factors that are mentioned. Well, what did they control? Gender. Let's back and call it truly controlled factors. Because they're using nothing but adult males. Age. Why would they control age? Well, do you think maybe someone who is 25 to 29 who tends to be in their more healthier years will react differently than someone who is 65 or older? Yep. So 25 to 29 is considered the healthier years, so we're going to test against them since we're not going to give them a drug. We're going to give them a placebo. All right. Two, what else could they have controlled? You think? Do you think maybe they controlled the location even though they didn't state it? You think someone in Florida, they're cold, how long it lasts is going to be different from someone like in Alaska or Michigan or Maine? I can tell you right now, even though it's not stated, they controlled for location. All right. What are some other factors do you think that they took into account or should have taken into account? Think about this. How about overall health? What do I mean by that? Someone who's 25 to 29, let's say they have diabetes, type 1 diabetes. You think that could affect how they fight a cold? Yeah. Someone who has cancer, definitely. How about autoimmune disease? Yes. So overall health, do they have like pre-existing conditions? Even at 25 to 29, odds are they checked for that. So that would be a factor that they're looking at. All right. How about other medications are they already on? Well, I guarantee they had to list that. That would be a factor. That's simple because what you're about to take interferes with drug you're already taking that you have to take. I mean, if you've got high blood pressure, they really don't want you taking cold meds. They have special cold meds for you because it drives your blood pressure even higher. So this is what I'm saying by overall health and drug interactions. They didn't state it, but I guarantee those are factors that went into a true study. All right. Now, there is also one factor that I guarantee they controlled. You think they didn't predetermine how much drug would be safe? Guarantee it. So there's another one I promise you they controlled that they didn't mention that, and that's definitely controlled. They don't give this person half a dose and this person double the dose. All get the same amount. And that would be still a controlled factor, but it's still a factor. So here's just some real quick ones, right? All right. So what do you think the treatments were? Well, treatment 1 would be the drug. Treatment 2 would be the placebo. Whether you're getting the drug or the placebo would be the treatment. Remember, it's what is it we're tweaking? What is it? The explanatory variable is really the treatment. What is it that we treat? Ah, man, this tonight I can't seem to speak. So how do we control factors that are not controlled? How do you think we deal with them? Well, that's dealt through the randomization. We're going to try to randomly put them in so that if we can't control it, we're going to put you randomly into group 1 or group 2. And odds are we're going to have more than one person with the same type of like high blood pressure. Some of them's going to be in the placebo group, some of them are going to be in the drug group. So it balances out. And what type of design? Well, since there's randomization going on by the assigning of which group, it's a randomized design. Who are the subjects? Those with colds. Now, this is where this gets a little fun. We literally draw flow charts when we're laying out designs. So there's the shapes. It's shapes I'm looking for. So how do we do this? Well, we start with oh, come on. And I'm trying to keep it short. Who are our subjects? It's the 300 men. Okay, fine. Remember, it said 300 men, right? That was our decision. I could put into that initial box the ages 25 to 29, but for room on this page, I'm kind of keeping it small. But it's the initial 300 men. And what was the first thing I did? I broke them into two groups. I have group one, who is getting meds, but it's made up of 150 men. And they're getting, I'm not there yet. I'm jumping ahead of myself. But they're made up of 150 men. Then I have group two. And guess what? They're made up of 150 men. So I took the initial 300 and I broke it into two groups. Now, what am I going to do with the two groups? Oh, come on. Fine. Let's give me fits here tonight. So what am I going to do with the two groups? Well, now I'm going to decide what are they getting? It's the treatment. So I'm going to give the group one the drug. Well, if group one is going to get the drug, that means group two is going to get the placebo. And yes, it is this simple when we're drawing these out. Oh, come on. This really is a flow chart type thing. So I took the 300, I divvied it between two groups. Then I decide what type of treatment. After that, I've watched, I monitored, guess what? I'm going to come back. And compare results. I'm going to compare / report results. Right? So this is a basic diagram that gets drawn, as I call it, during the brainstorming stage of the design. How many people? I start plotting and laying it out. But I always know I'm going to start with the group of people. How am I going to break it up? What if I'd done 3 groups? Well, then I'd put 100, 100, 100. So I'd have had 3 boxes stacked here. Yet they get a lot more complex. And then what am I going to do? This group's going to get 1. This group's going to get so 31. So I'd have had 3 different things going on. Maybe I have 2 different treatments. Treatment 1, then treatment 2. But it always starts out like this, and then it comes back at the end, back together, where I compare and report the results. This is called diagramming a designed experiment. It's a type of flow chart. All right. So let's talk. Well, not real sure what this is. That's the exact same thing we just did. I changed this a while back. So I must not have completed changing it. So I apologize. The last thing is talking about other types of design. We just walk through a randomized. Well, we also do something called matched pair. Matched pair design is we pair people up. And they need to be related in some way. And twins are wonderful when we get twins into it. That's my biggest thing that I can talk about on matched pair. But we're going to take people that are paired up and call 1A, 1B. And we're going to set it up just like we did with the designed, except we know that group 1, instead of being random, there's something about the person going into group 1 matches to somebody in group 2, whether they are twins, siblings, husband, wives. Maybe it could be about the location they live. We're comparing 2 people that live in the same apartment building. Things like that. There has to be something that's common between 2 subjects, but every subject in the group, they're paired against somebody else. So I may have in a paired design 300 people, but of those 300 people, everybody in there, so now there's 150 people here, everybody in that 150 shares something with somebody over here. Whether, again, maybe I have 300 siblings. Sibling 1 goes here, sibling 2 goes here. That's the easiest way I get students seeing this. Could be dog owners. I have group one who, if you own, Labrador, age 2, then there's someone here in this group that owns a Labrador similar to your dog, same age. Has to have a match. All right. Because there's also only 2 levels of treatments in this case. In other words, I'm not going to do 3 groups. Where in a random design, I could have 3 groups. I could have 4 groups. In a matched pair, because it's a pair, there's only going to be 2 treatments. Period. All right. Now, blocking is when we take a group of people that share the same, or not just people, could be subjects. We take a group of subjects that share certain variables, certain factors. And it's very controlled. And we put them all in the same group. That process itself is called blocking. Each group would be called a block. The randomly dividing the group is called randomized block design. Well, guess what? This is a form of randomized block design because I have a group of people, 300 men, same age. They're sharing the same, same things. I could have taken it down further. Maybe it's not just gender. Maybe I'm going to take it down to race only. Maybe I'm going to take it down to a specific city. But when I go to block, I'm controlling it down to 300 people that share all the same factors as much as possible. Again, factors are variables, the descriptions. Okay. So there's lots of things. Think of how many different ways you can describe somebody. Talked about that back previous sections. Okay. So blocking, there are all these different types of methods are similar, but they're slightly different. This alone, the only thing I really controlled initially was just, I said 25 men, age this, to have a cold. Okay. Then I broke them in 2 groups. Then I said, what? I tweaked it down further. They're all siblings. Then here, I took it further. So again, it's like I'm tightening the controls as each further tightening or constraint I put on it changes the design name by a little further. All right. Ladies and gents, that is section 1.6. I hope you're getting this. And things, I'm not confusing you too bad yet. All right. I smile when I say that, yet. But chapter 2, we're going to start taking more into the statistics a little bit. As I promised, I'm sorry, chapter 1's a little on the boring side. I'm laying groundwork and getting you guys to understand why we do what we do. Okay. That's it for 1.6. You made it through chapter 1. Congratulations. Oh, stop sharing. Come on. There we go.